searching in an array is the most important operation of all. More often than not, it comes down to the speed of searching for an element in a database that helps programmers to make decision choices for their code base. There's more than one way of searching an array, but for now, we are going to focus on the simplest way. Searching means to find an occurrence of a particular element in the array and return its position. We may need to search an array to find out whether or not an element is present in this array. When inserting a new element into an array, we should determine which index should we insert it. So before that, we need to search in this array, and this array is arranged in a specific fashion. If we know the index in the array that may contain the element we are looking for, then the search becomes a constant time operation. We just simply go to the given index and check whether it is not the element is there. If the index is not null, which is the case of most of the time, then we can check every element in the array. We continue checking all of the elements until we find the element we are looking for, or we just reach the end of the array. This technique to finding an element by checking through all the elements one by one is known as a linear search algorithm. In the worst case, a linear search algorithm ends up by checking all of the entire array. Therefore, the time complexity for a linear search is O of n. First, let's create a public class. Public class array search, and under the main method, we create our own method. Public static boolean. This is judge whether it exists or not. We call the method linear search, and within is a integer array integer length integer element, and inside the method we need to check for the edge case. If array is known, or if the length is 0, that's be empty. So if array is none or empty, we return false. So if it is empty, we return first. That means because the element we search couldn't be possible find in empty list, empty array, right? And then we carry out the linear search by checking each element. Start from the first one. Enter I is 0, I less than the length, and I the increment, and we found the element at I, and then if it is true, that means array at I is happened to the element we want to find, and return true because we find the array at I is the element we want to find, and this is this integer is an input, right? For we want to search, and you see if statement, for statement, and enter the function. If we didn't find, we just return false. Yeah. So we need to declare the new array. In the main method, we declare a new array of 6 elements. Integer array is a new integer 6 element, and we need to declare a variable to keep track of the length of the array. Int length is 0, and we need to iterate the 6th index of the array. For int I is start from 0, I less than 6, and I increment. So inside it we have to add a new element by increment the length array. The length plus plus is to get the value from I. And then we just print out the result. System.out.println. Does the array contain the element 4? Plus array search dot Boolean search. This is a array length, and the element is 4, and we can repeat again to find a number at 30. Let's try to run it out. Oh, does the array contain element 4? True. Does the array contain the element 30? False. So we are done. When I said edge cases, I basically mean the scenario that you wouldn't expect to encounter. For example, the element you're searching for may not even exist in the whole array, or an even rare but possible is this scenario is that the input array doesn't contain any element at all, or perhaps it is a null. It is important to handle all of the edge cases within your code. That's the function we can call to determine whether or not a particular element exists in an array. Notice how we take care of the edge case before proceeding the actual search. Once we found the element we are looking for, we don't check the rest of the elements. There are many variants to this algorithm, such as returning the first location, last location, or all of the location. An element could be in the array more than once.